an object falls from rest from a height h. So initial total energy is ek plus ep, but as the initial velocity is 0, the kinetic energy would be also 0. So this would be equal to mgh, which is this mgh. And here's h, here's 4 over h. And at this point, the potential energy would be mg, so 1 over 4 mgh at this point. And as the total energy is conserved, at this point the kinetic energy would be E total minus E potential, so mgh minus 1 over 4 mgh, so it's 3 over 4 mgh at this point, equal to, so this goes here, so mgh and mgh, these two cancels out, so the answer would be 4 over 3, giving us the answer of A. Okay, the power of the car, P equals force times by velocity, and as the force is given as 1500 and velocity is distance over time, so 100 over 5 gives us 20 meters per second. So this goes in here times by 20, so giving us 30 kilowatts. Answer D. Here it's asking us about the speed, so v u plus at, and as it says object is at the rest, so u would be 0 and v equals at. And in this graph, the at would be the area under the graph, as here's t and here's a. So when the object is 15, the area under the graph would be this here, okay, like this. So the area for this triangle would be 10 times 5 times 0.5 plus, and the area for this rectangle would be 5 times 5. 25 plus 25 gives us 50 as the velocity. Average speed is displacement over time, so it's 50 meters over 15 seconds, so this is about 3.3 meters per second. And instantaneous speed can be get from the graph, so when the time is 15, the velocity is 5, so it's 5 and it's 3.3, so it's C. So which area represents the work done? W equals force times distance. And during the motion from P to Q, so force times distance would be the area under graph here, and as it's from P to Q, it would be the area here. So it's Y and Z. C. Okay. Which objects collide and stick together? What is the total change of linear momentum of the objects as a result of collision? According to conservation of momentum, the total linear momentum of a system of interacting particles remains constant provided that there's no resultant external force. And as we can see, there's no external force acting onto objects, so we can assume that the momentum is being conserved. So there's no change for the momentum for this question. So it would be 0.